Okay, so hey there everyone. I'm going to be giving a quick overview on HTTP, so let's go ahead and dive in. Quick facts. So Hypertext Transfer Protocol is the name of the game. Basically, it's the underlying protocol used by the World Wide Web. Foundation of any data exchange on the web. It's client-server protocol. So basically that just means that requests are initiated by the recipient, and usually that's going to be a web browser. So moving on. So basically the complete document is just going to be reconstructed from all these different subdocuments that are fetched. It's going to be your text, layout, description, images, video, scripts, etc. It's your basic website, your basic web page. Just all the little elements, image, video, all this kind of stuff. So basically, client servers communicate by exchanging individual messages back and forth. Messages are going to be sent by the client, usually a web browser, and those are called requests. And the messages sent by the server, okay, as an answer are called responses. So basically, so HTTP is a transport. It's an application layer protocol, and it's on top of the TCP transport layer and IP network layer here. So basically, as mentioned before, it's a client-based or client-server protocol. Basically, that is meant that the requests are sent by one entity, user agent, or a proxy on behalf of it. And most of the time, the user agent, like I said, is going to be a web browser. Can be anything. So basically, thanks to the layer design of the web, those things are hidden in the network and transport layers that we just viewed a moment ago. So, like we said, you have HTTP on top and application at the application layer. Basically, okay, so your user agent, that is going to be any tool that acts on behalf of the user. And again, that's just a role primarily performed by the web browser. Then you got your web server, that's on the opposite side of the communication channel, just serves the document as requested by the client. And then you've got your proxies in between all that. Between it, numerous computers and machines are going to relay those HTTP messages. So anyway, just a few proxy functions. We've got caching, filtering, load balancing, authentication, logging, just to name a few. Moving on to our basic aspects of HTTP, to give a kind of little reiteration. It's just simple. It was designed to be human readable, even with HTTP2 that came around later. It's extensible. Basically, that just means that it is able to extend and be experimented with. New functionality can even be introduced by a simple agreement between a client and a server about a new header semantics. So it's also stateless but not sessionless. So there's no link between the two requests being successively carried out on the same connection. Speaking of connection, the connection is controlled at the transport layer and therefore fundamentally out of scope for HTTP. Though HTTP doesn't require the underlying transport protocol to be connection-based. It only requires it to be reliable, or at least not lose messages. So at a minimum, present an error, so to speak. So moving on, what can be controlled by HTTP? So basically, the extensible nature of HTTP has, over time, allowed for more control and functionality of the web. So here's just a list of some common features. You'll see a little overlap here. Caching, relaxing the origin constraint, authentication, proxy and tunneling, as well as sessions. And just notably, cache or authentication methods were functions that were handled early in HTTP history, but actually the ability to relax the origin constraint wasn't actually added until the 2010s. So, fun fact. Okay, so talking a little bit about HTTP flow. So basically when a client wants to communicate with a server, either the final server or an intermediate proxy, it's going to perform the following steps. So first, you're going to have to open a TCP connection. Second, you're going to have to send an HTTP message. And there's just a quick example of one of those sent HTTP messages. Third, you're going to go ahead and read the response sent by the server. So here's just another example of that response. And finally, fourth, there'll be close or reuse the connection for further requests. So pretty simple, straightforward. If HTTP pipelining, though, is activated, several requests can be sent without waiting for the first response to be fully received. This is actually proven difficult, though, to implement in existing networks, where old pieces of software coexist with modern versions. So HTTP pipelining has been superseded in HTTP 2 with more robust multiplexing requests within a frame. So, moving on to HTTP messages. So as defined in HTTP 1.1 and earlier, these messages are actually very human readable, so that's good for you and me. But actually in HTTP 2, these messages are embedded into a binary structure, a frame, so allowing optimization like compressions of headers and multiplexing. So, good for user experience, but not so much for human readability. So just to give you an example, HTTP message request, because there are actually two types of HTTP messages, requests and responses, naturally. Each has their own format. So your basic HTTP request is going to have an HTTP method. Here, the path of the resources to fetch, the version of the protocol, HTTP protocol that is, optional headers, or a body. So pretty simple stuff. And moving on to responses, very similar to requests. So basically this is going to have, again, version of the HTTP protocol they follow, status code, so here we see it's okay, HTTP headers, and as well as status message. Status code was the 200, status message is okay. And then optionally there's going to be a body containing the fetched resource. Okay, so just to, now that we've kind of looked at all that, just to give you guys a little bit of an idea of some APIs based on HTTP. So the most commonly used API based on HTTP is actually this XML HTTP request API, which can be used to exchange data between a user agent and a server. The modern, though, fetch API, right here, actually provides the same features, but with a more powerful and flexible feature set. So you're getting a little more bang for your buck with this fetch API, newer, more robust. And then just real quick, another API, the server sent events, is a one-way service that allows the server to send events to the client using HTTP as a transport mechanism. So using the event source interface, the client opens a connection, establishes event handlers, and then basically the client browser is going to automatically convert the messages that arrive on the HTTP stream into the appropriate event objects, and then it's going to deliver them to the event handlers that have been registered for the events type, if known, or to the on-message event handler, if no type-specific event handler was established. So that kind of got a little hairy there, but just want to touch on a few APIs. So just to wrap things up, in conclusion, basically, HTTP is pretty simple. It is extensible protocol. It means it's extendable, easy to use, and everyone on the internet benefits from it, whether they know it or not. So, again, thank you for your time, and to all you folks out there, enjoy all those lovely web pages, thanks in part to HTTP. Alright, thanks.